School's online till summer. School's online with Blackboard. School's online with Zoom meetings.
Hello everyone, welcome back to a wonderful day in financial administration. Today we're going to calculate the values of uneven income streams, calculate loan payments, and then create an amortization table. Before we do that, I wanted to talk about a perpetuity, and that's something where you'd receive a payment forever, and you can calculate that. It's similar to a pension, where you get paid until you die. The way to calculate a perpetuity is to take that payment that you're getting and divide it by the current interest rate. That will give you the value of the perpetuity. Now, so far we've been talking about getting the same payment over and over again when we talk about annuities. But you don't always get the same payment. Sometimes you're going to get uneven cash flows. And I'll give you an example. Let's say we were going to get $200 1 year from now, $300 2 years from now, and $400 3 years from now. And currently our money makes 10% interest. What would be the present value of that? Well, there's a couple ways we could look at it. We could take each one of those sums and put them into a present value. So we could say the present value of $200 1 year from now with 10% interest is $181.82. And the present value 2 years from now of $300 at 10% interest is $247.93. And then we could calculate the present value of receiving $400 3 years from now at 10% interest and get $300.53. We could then add up each one of these individual present values to get a total present value for that uneven income stream. Now that's a lot of work. Instead, what we're going to use is the equals NPV function. Here, let me show you how it's done.
The way we use the equals NPV function is by hitting equals NPV. Then we open the parentheses. The first thing it asks for is the rate. In this case, it's 10%. Then it says value number 1. That's going to be the value after 1 year. In this case, we were getting $200 after 1 year. The next one is going to be the second year value. In this case, we were getting $300. And the third one is going to be the third year's, and so on. Since we only have 3 values, we can close out the parentheses and hit equals. And it gives us the present value of this uneven income stream. I'm going to open it up so that you can see what this is. One thing to note when using the NPV function is that if we have these values written out for us, 200, 300, and 400, we can use this formula and identify the cells. So if I hit equals NPV, open parentheses, interest rate 10%, then I hit comma, the first value is 200, and I just select all the way down to 400. Excel is going to assume that each one is the next year's value, and I can hit enter.
So far, we've been looking at interest compounding annually. So when we put in the rate, it's going to be that interest rate for the year. And when we put in the number of periods, it's going to be number of years. But we can adjust this if needed. So if the interest rate is compounding more frequently than just every year, we can make those changes and still do the calculations. To adjust our interest, we're going to divide the interest rate by the number of compounding periods. So for example, if I had a 10% interest rate annually, but I was going to compound it every 6 months, I would adjust the interest by taking that 10 and dividing it by 2 because it's going to compound twice per year. I would also adjust the number of periods. So back to that example. If I had 10% interest that was compounding every 6 months, that would be 5% interest per period. I would also have to increase then the number of periods. In order to adjust the periods, you multiply that number by the number of compounding periods. So 10% annual interest can be changed to 5% interest compounding twice if it's every 6 months. Let me do an example. If I had 4% annual interest that was compounded quarterly, what would be my new interest rate? Right, it would be 1%. 4% divided by 4 compounding periods. What would be my new number of periods? That's right, 4. It used to be 1 period, but now it's compounded 4 times a year. 1 times 4 makes 4 periods. Now we're going to talk a little about amortization charts. When you have a loan, you pay more interest in the beginning of the loan payback than you do at the end. And that's based on the amortization chart. In order to create an amortization chart, we first would need to figure out what our payment would be. In order to calculate that, we're going to use the equals PMT function. Here's an example. I take out a $10,000 loan at 4% interest, and I need to pay it back in 5 years.
To calculate the payment, I'm going to use the equals PMT function. Open parentheses. It asks me for the rate, which is 4%. It asks me for the number of periods, which is 5. Anytime you're talking about payments, you're talking about a loan, so it's always going to be present value because you get that loan money today. So the present value is going to be negative 10,000, and then I can click enter. This will tell me that my payment is going to be $2,246.27 when I'm looking at this loan. This is what the formulas look like.
Again, when we're calculating these payments, we need to make sure we're using the equals PMT function. Identifying the payment is the first step in creating the amortization chart. Once you know what the payment is, you need to determine what portion of that payment is going to pay interest and what portion of that payment is going to pay down the principal.
The way you make an amortization chart is you have the payments in this column. This next column is going to be the interest percentage. This next column is going to be the interest dollars. This next one will be the principal dollars. And then offset by 1 will be the balance. We can fill this out from the prior example by taking $10,000 because that was our loan balance. Our interest percentage was 4%. We've calculated our payment as $22,46.27. I can pull this down for each one of the 5 years since that will be our payment. We have now completed the payment column. The way an amortization chart works and the way you pay back a loan is that every year you have to pay the interest percentage on your outstanding balance. So in year 1, we need to pay 4% times this $10,000 that we borrowed. That means in the first year, we are paying $400 of interest. But our full payment is $2,246.27. So some of that payment can go to principal and lower our balance. We can find out exactly how much that is by taking our payment and subtracting out the portion that's going to interest. This results in a principal reduction of $1,846.27. Our new balance will then equal our prior year's balance minus the portion that went to principal. Now we have a balance of $8,153. I'm going to open up these formulas so you can see how it worked. We see that we have the balance here, which is $10,000. We've put that in, and the interest rate here is 4%. I'm going to move these cells over a little bit so we can also see our payment. Again, we put in this interest percentage and this balance. We figure out our interest by taking our balance and multiplying it by our interest percentage. That gives us our interest dollars here. We then can figure out what portion of our payment goes to principal by subtracting out the portion that's in interest dollars. This gives us our new balance. These are the only formulas you need to know in this equation when creating an amortization chart. The reason for this is when I toggle these formulas off, what I can do is copy my interest rate for each year at 4%, then highlight these three rows that have my formulas, pull them all the way down, and I will have a completed amortization chart that shows a zero balance at the end. We'll do another example of this later on today.
We're going to do some practice now. You get an offer to receive $2,000 a year forever. What is that worth in today's dollars if you make 6% interest?
To calculate a perpetuity, we would take the payment, which is $2,000, and divide it by the interest rate, which is 6%. In today's dollars, receiving $2,000 a year forever would be worth $33,333.
Here's another one. You're getting a boat. The loan of $25,000 is for 4 years at 3% interest.
You're getting a boat.
What's your
The
annual
loan is
payment?
for $25,000, 4 years, and 3% interest. What is your payment? We're going to use the payment function, which is equals PMT. The interest rate is 3%. The number of periods is 4 years. And a loan is always present value, so that's going to be $25,000 in present value. We get that the payment on this boat would be $6,725.68.
That's great, but how much interest are you going to pay in year 2?
To calculate how much we're going to pay in year 2 in interest, we need to create an amortization chart. We'll put the payment in for each of the 4 years. We'll put in the interest rate at 3% for each of the 4 years. We don't know the interest dollars yet. We'll have to calculate that. We don't know the principal dollars yet. And we do know the balance, and it's offset by 1, and it's $25,000. I will label these again. Balance, principal dollars, interest dollars. We always have to pay interest on our outstanding balance. We pay 3%, so that will equal our balance times this interest rate. In the first year, we will pay $750 of interest. Since our payment, though, is $67.25.68, there's going to be money left over after we've paid our interest. That will go to lower the balance. It'll be part of the principal payment. that will equal our payment minus the portion that's going to interest. After we've paid our interest in the first year, we can lower our balance by $5,975.68. Our new balance will equal our prior year's balance minus the portion that we were able to apply to principal. We now have a new balance of $19,024.32. Because these are set up as formulas, we can highlight these three cells and pull them down. And you will see again, after 4 years, there's no more balance left on our loan. The interest in year 2, we are paying $570.73.
If you get 12% annual interest compounded monthly, what will a one-time deposit of $500 be worth in 7 years?
In order to calculate this, we're going to have to adjust the interest rate. So we're calculating future value because we want to see what it's going to grow to. The interest rate is 12%, but since it's compounded monthly, we need to adjust that by 12 because there's 12 monthly periods in a year. The number of periods is 7 years, but again, we need to adjust that because there's 12 months in the year. So we'll multiply that 7 years times 12. There are no payments, and we said we were putting in $500 today. If I hit enter, I get that $500 will grow to $1,153.36 in 7 years if we have 12% interest and it's compounded monthly.
So as you can see, we can adjust both the interest and the number of periods within that Excel formula. You have the opportunity to earn $200 in 1 year, $400 in 2 years, and $500 in 3 years. Your money earns 6%. Would you pay $950 today for that opportunity?
This next question is asking about an uneven income stream. It says $200 in the first year, $400 in the second year, and $500 in the third year. It says our money earns 6% interest, or we have the opportunity to take $950. I know how much $950 is in today's dollars because it's $950. What I don't know, though, is how much $200 1 year from now, $400 2 years from now, and $500 3 years from now is worth in today's dollars. But I can calculate it using our NPV function. Equals NPV. First thing it asks for is the interest rate. Instead of typing it in, I'm going to point to the cell. So our interest rate is here in cell D2, which is 6%. I'm then going to hit a comma. It asks me for the first year's value. Instead of typing each one individually, I'm just going to highlight all three. I can now hit enter, and I get that this uneven income stream right here is worth $964.49 in today's dollars. I would rather have $964.49 than $950, so I would pay $950 today in order to get that opportunity because it's worth more than $950.
You're getting a new car. The loan of $35,000 is for 5 years at 5% interest. What would be your annual payment?
So this is another payment calculation. So we'll use the equals PMT function. The interest rate is 5%. The number of periods is 5 because it's 5 years. And again, loans are always in present value because you get the money today, which is $35,000. I get a payment of $8,084.12.
How much interest are you going to pay in year 4?
To calculate the amount of interest I'm paying in year 4, I need to create an amortization chart. I will copy the payment down for each one of the 5 years. Next, I put in the interest, which is 5%, and I copy that all the way down as well. I don't know what the interest dollars are yet because I haven't calculated them. I don't know what portion goes to the principal because I haven't calculated that either. I do know what the balance is. The loan itself was for $35,000, so that's my current balance. The first year, I owe 5% interest on the outstanding balance. So the interest that I owe for the first year is 5% times $35,000. I owe $1,700, $1,750 in interest, but I'm paying $8,084. So I'm paying more than the interest, and I can figure out that number by taking my full payment, subtracting out the portion that goes to interest, and I get that I've paid $6,334.12 beyond what I owed in interest. I can use that additional part of the payment to lower the balance. I take my balance and subtract out the portion that went to lower it, and I get my new balance is $28,665.88. Because I set these up as formulas, I can pull them down because each year it's going to be doing the same thing. You see a zero balance here. You see that in year 4, I had a $15,031.69 outstanding balance times 5% interest, resulted in an interest of $751.58 in year 4.
If you get 6% annual interest compounded every 6 months, what will a one-time deposit of $1,000 be worth in 4 years?
For this, we're going to have to adjust the interest. So this is asking what a deposit today is going to be worth in 4 years. So that's future value. The interest rate is 6%, but it's compounded every 6 months. So we need to divide that by 2 because there's 2 periods of 6 months in a year. The number of periods is 4 years, but because it's compounded every 6 months, we're going to multiply that by 2 because it's going to end up with 8 compounding periods. We didn't say multiple payments. We did say we'll put in $1,000 today, so that is the present value. And we get that if we put $1,000 into the bank today and it receives 6% interest compounded every 6 months, in 4 years it'll grow to $1,266.77.
Here's another one. You have the opportunity to earn $300 in 1 year, $700 in 2 years, and $900 in 3 years. Your money earns 8%. Would you pay $1,600 today for this opportunity?
We have another opportunity here where we need to find the value of an uneven income stream. It says we'll get $300 in year 1, $700 in year 2, and $900 in year 3. It says that our money earns 8% interest. And they're looking at, would you pay $1,600 today in order to get this cash flow stream? We know how much $16,000 is worth today. It's $16,000. What we don't know is what this uneven income stream is worth in today's dollars. We can calculate an uneven income stream by hitting equals NPV. First thing it asks for is the interest rate, which I'm going to identify here in this cell as D2. Then it asks for the values. Instead of putting them in separately, I'm just going to highlight all 3. If I hit enter, I can get that this uneven income stream is worth $1,592.36 in today's dollars. I would not pay $1,600 for it because it is not worth $1,600.
Here's a choice. You could get $600 for 5 years with your first payment coming today. Or you could take a lump sum today. If I could invest at 5%, what would be an equal lump sum?
Okay, so I have a choice here. I can get $500 for 5 years with the first payment today, or I can get a lump sum So I need to figure out an equivalent lump sum. So we're talking about present value because I need to know what it is in today's dollars. Interest rate, 5%. Number of periods, 5 years. Multiple payments, yes, $600. Future value, we don't know that. And it did mention that my first payment is coming today, so I will put a 1 because this is an annuity due. If I hit enter, I can get that the equivalent lump sum is $2,727.57. That lump sum is also the present value because that's what it's worth in today's dollars. So that lump sum would also come today.
I don't know if you know this, but I need hair plugs. And I want to get them in 3 years. So I want to have $5,000 in 3 years. I can invest at 8%. What do I need to deposit today for it to grow to $5,000 in 3 years?
Okay, I need to know what I'm depositing today. So that's going to equal present value. So equals PV. The interest rate is 8%. The number of periods is 3 because I need it in 3 years. It's not multiple payments, but I know I need to grow to $5,000 in order to have my money. I can then close it out, and if I put in 39, 69, 16 today, it will grow in 3 years to the $5,000 I need.
Hey, guess what? You're getting a tractor. The loan of $5,000 is for 4 years at 7% interest. What would be your annual payment?
Okay, we need to calculate a payment again, so that equals PMT. It asks for the interest rate, which is 7%. It asks for the number of periods, which is 4. Loans are always in present value, so that's going to be $5,000. We calculate that our annual payment is $1,476.14.
That's great, but how much interest do you pay in year 2?
Now we want to know how much interest we're going to pay in year 2, so we need to create an amortization chart. So I'll pull down this formula. We put in the interest rate at 7%. We don't know how much we're paying in interest dollars yet. We don't know how much we're paying in principal dollars yet. We do know the balance. It's offset by 1. And it's going to be $5,000. We owe 7% interest in the first year on whatever we owe, which happens to be $5,000. So 7% times 5,000 equals $350. Because our payment exceeds $350, there's money left over to lower the balance. So we take our payment, subtract out the portion that's going to interest, and we get $1,126.14. That excess of the interest that's owed can be used to reduce our balance. $5,000 minus the amount that can go to principal gives us a new balance of $3873.86. We'll put the interest rate through the rest of the years. Now we can just select these 3 cells and pull down the formula, and it will update the amortization chart with a 0 balance after the 4th year. In the 2nd year, we pay $271.17 in interest.
So I know these calculations can be complicated, but keep in mind that we're going to be doing this type of thing for the rest of the semester. So you'll have additional practice on this, additional homeworks on this, and we'll continue to go over these. Today, again, we talked about calculating values of uneven income streams, calculating loan payments, and creating amortization tables. I hope you guys have a really nice day, and I hope to see you all soon.